The Dynamic World of Chemical Reactions with Max Axiom, Super Scientist. Section 1, Reactions Around Us. Super Scientist Max Axiom begins thinking about chemical reactions while enjoying an evening bonfire. Nothing's better than a fire on a cool night. Burning is one of the most important chemical changes or reactions around. Chemical reactions happen when one substance is changed into a new substance. In a fire, wood changes into ash and smoke. But fire isn't the only chemical reaction you can see. From exploding fireworks to flashing fireflies, we're surrounded by chemical changes all the time. People have used chemical reactions for a long time. For example, humans have used fire for cooking, light, and warmth for many thousands of years. Later, people discovered they could make their bread lighter and tastier through the chemical reaction of fermentation. Fermentation. Access granted, Max Axiom. Fermentation can be used to produce various foods and beverages. It results when bacteria or yeast digests simple sugars. This digestion process gives off carbon dioxide gas and ethyl alcohol. It is the release of carbon dioxide gas that makes bread dough rise. But they also experimented with mixing chemicals. By the mid-800s, the Chinese combined sulfur, charcoal, and potassium nitrate to create an explosive mixture. They called it hu yao, or fire drug. We call it gunpowder. Over time, scientists found ways to use gunpowder as a military weapon. Gunpowder burns rapidly and produces gases that sends bullets, cannonballs, and fireworks flying. Chemical reactions definitely have a long and exciting history. Let's take a closer look at how they work. Section 2, Matter, Atoms, and Molecules. To understand chemical reactions, you have to understand matter. Matter makes up everything in the universe. Galaxies, stars, and planets are all made of matter. Everything alive is made of matter, including plants, animals, you and me. Everything around us, including the air we breathe, is made of matter. And all matter is made up of tiny particles called atoms. Some atoms combine with other atoms and stick together in groups called molecules. Let's see how they work. Inside the atom. Access granted, Max Axiom. Atoms can be broken down into even smaller particles called neutrons, protons, and electrons. Protons and neutrons stick together at the center of the atom, called the nucleus. Electrons whiz super fast all around the nucleus. Imagine taking a drop of water and splitting it in two. Now split it again, and again, and again. Eventually, you'd split the drop down to a single molecule of water. And if you looked closely, you'd see its basic structure. A water molecule is made up of one oxygen atom and two hydrogen atoms. Tiny, tiny atoms. It can be mind-boggling to think about the very small size of atoms. There can be a few sextillion, a 1 followed by 21 zeros, atoms in a drop of water. Can you imagine 1 sextillion of anything? In all, 117 types of atoms combine in different ways to make all the matter in the universe. Some types of matter are made up of only one kind of atom. Copper, for example, is made only of copper atoms. These substances are called elements. Let's talk to a chemist and learn more about them. Molecules. Access granted, Max Axiom. Carbon dioxide. Molecules are made up of two or more atoms joined together. A molecule can be made up of the same or different atoms. For example, a molecule of oxygen is made up of two oxygen atoms. On the other hand, a molecule of carbon dioxide is made up of one carbon atom and two oxygen atoms. Hi, Dr. Chen. I was hoping we could talk about elements. Sure, but which ones? Each element has specific physical and chemical properties that help us identify it. Sodium, for example, is a soft silvery colored metal. It reacts explosively with water. Chlorine gas has a yellow-green color. It is also poisonous. Elements can combine to form substances called compounds. These substances have a specific recipe to create them. The compound water, for example, has 2 parts hydrogen and 1 part oxygen. And just like elements, compounds have specific physical and chemical properties. Take the compound sodium chloride, or NaCl, for example. It is made up of 1 part each of sodium and chlorine. While you wouldn't need either sodium or chlorine by themselves, together they make clear, harmless table salt. Periodic table of elements. Access granted, Max Axiom. The periodic table of elements lists all the elements. It shows the physical characteristics of each element and helps scientists predict how elements will react when mixed together. On the periodic table, each element has its own symbol. Hydrogen's symbol is H, oxygen's is O, carbon's is C, chlorine's is Cl, and sodium's is Na. Section 3. Changing matter. Matter can change in 2 ways. It can have a physical change or a chemical change. Physical changes only change the physical properties of a substance. Its chemical makeup stays the same. I can crumble a piece of paper, but it's still paper. I can hammer gold into a different shape, but it remains gold with all the same chemical properties. Liquid water can be frozen into solid ice or heated until it turns into steam. The physical form of water is different, but ice, steam, and liquid water are all still made up of water molecules. It's fairly easy to uncrumple paper, melt gold, or change water from one form to another. These are all physical changes. But chemical changes are different. A chemical change turns the substance into something new. It changes the substance arrangement of atoms. I'm going to take a closer look. Let's shrink down to the size of molecules to see what happens in a chemical reaction. I'm going to change this water molecule into something completely different. How? By changing the way the atoms are joined to each other. Water, or H2O, is made up of 1 oxygen atom and 2 hydrogen atoms. To chemically change it, I'll add another oxygen atom to the molecule. Now, I don't have water anymore. I have a disinfectant called hydrogen peroxide, or H2O2. It's a completely new substance. All burning involves chemical change. Chemical reactions change both the physical and the chemical properties of a substance. If I burn paper, I'm left with ashes and smoke. I've changed the paper chemically. It is now made up of a different arrangement of atoms. I can't turn it back into paper. Many chemical reactions can't be undone easily. Some can't be undone at all. Have you ever tried to unfry an egg or get the flour and water back out of a baked cake? Chemical reactions happen when 1 or more substances change to form 1 or more new substances. But the new substances only contain the atoms present in the substances that reacted. If I combine carbon with oxygen, I get a new product. The new compound won't contain any other atoms besides carbon and oxygen. Chemical reactions involve the making, breaking, or rearranging of chemical bonds. Chemical bonds hold the atoms in a molecule together. These bonds are sometimes formed by the atom's outermost electrons. In a water molecule, the hydrogen atoms share their electrons with the oxygen atom. Reactants and products. In a chemical reaction, the substances that undergo a chemical change are called the reactants. The substances that result from the change are called the products. There are all sorts of chemical reactions. In a combination reaction, 2 or more substances combine to form the product. The formation of water from hydrogen and oxygen is a combination reaction. A decomposition reaction breaks down a substance into simpler parts. In strong light, hydrogen peroxide, or H2O2, decomposes into water, H2O, and oxygen, O2. That's why hydrogen peroxide is stored in dark bottles. If it wasn't, it would turn into water. But in all these different reactions, one thing remains constant. No matter is created or destroyed during a chemical reaction. It may seem like stuff is missing when you compare a log to its ashes. But imagine if you carefully collected all the scattered products of the gases given off. You'd find that the combined products weighed the same as the original reactants. Section 4. Dynamic reactions. Depending on whether chemical bonds are broken or formed, a reaction can give off heat or take in heat. Chemical reactions that take in energy are called endothermic reactions. Photosynthesis is an endothermic reaction. During photosynthesis, plants take in energy from the sun and use it to make food. Reactions that produce heat and give off energy are called exothermic reactions. Danger, explosion today. Explosions are dynamic exothermic reactions. They happen when an exothermic reaction quickly produces huge amounts of gas that have nowhere to escape. Kaboom! The gases produce enough pressure to explode the container, ground, or building in which they are trapped. Combustion or burning is always an exothermic reaction. It gives off energy and heat. Burning fuel helps run our vehicles. Unfortunately, combustion can sometimes be deadly. A fire keeps burning as long as there is fuel, oxygen, and heat to drive it. In a house fire, the fuel is the materials in the house that can burn. Firefighters do their best to get rid of one of the ingredients to put out the fire. Water helps absorb the heat of the fire. It cools the burning materials so they can no longer burn. Foam extinguishers work to smother flames by cutting off a fire's oxygen supply. But not all chemical reactions are as fast and explosive as combustion. Some reactions can take years to form. Take rust, for example. In the presence of water, iron combines with oxygen in the air to slowly form rust. Our bodies use chemical reactions too. They help us break down and digest food to keep us alive. And chemists are always trying to find new reactions to make new things. Chemical reactions have created medicines, fertilizers, detergents, plastics, dyes, and more. And let's not forget the chemical reactions that make our food delicious. Baking a cake uses many different chemical reactions. Cakes rise because carbon dioxide gas is released from baking soda. We use chemical reactions in every part of our lives. In fact, we couldn't live without them. More about chemical reactions. Elements are the simplest forms of matter. There are 117 known elements in the universe. About 90 of these elements are found naturally on Earth or in the atmosphere. The others have been created in laboratories. Scientists are still working on discovering new elements. A molecular formula tells you the total number and kinds of atoms in a molecule. Water's molecular formula is H2O. That means to make a molecule of water, you need 2 atoms of hydrogen, H, and 1 atom of oxygen, O. Carbon dioxide's formula is CO2. That means you need 1 atom of carbon, C, and 2 of oxygen, O, to make a carbon dioxide molecule. Fireflies glow because of a special reaction involving oxygen atoms and 2 other chemicals. The chemical reaction takes place in the firefly's abdomen. The light produced shines right through its body. Heating chemical compounds produces the beautiful colors you see in fireworks. When heated, the compounds give off colors. To get blue, firework experts add copper compounds. To get orange, they add calcium. New York's Statue of Liberty is green thanks to chemical reactions. Made of copper, the statue was originally the color of a penny. But over the years, the copper has reacted with oxygen in the air, or oxidized, to form the statue's famous green coating. Have you ever made a volcano using baking soda and vinegar? The resulting lava is made by a chemical reaction. The baking soda and vinegar react to produce water, sodium acetate, and lots of fizzy carbon dioxide gas. Acid rain is caused by sulfur dioxide and nitrogen oxides that are released into the atmosphere by human pollution or natural events. These chemicals react with water, oxygen, and other compounds to form acid rain. Acid rain has harmful effects on the environment, wildlife, and humans. More about Max Axiom, super scientist. Real name, Maxwell J. Axiom. Hometown, Seattle, Washington. Height, 6 foot 1 inches. Weight, 192 pounds. Eyes, brown. Hair, none. Super capabilities, super intelligence. Able to shrink to the size of an atom. Sunglasses give X-ray vision. Lab coat allows for travel through time and space. Origin. Since birth, Max Axiom seemed destined for greatness. His mother, a marine biologist, taught her son about the mysteries of the sea. His father, a nuclear physicist and volunteer park ranger, schooled Max on the wonders of earth and sky. One day, on a wilderness hike, a mega-charged lightning bolt struck Max with blinding fury. When he awoke, Max discovered a newfound energy and set out to learn as much about science as possible. He traveled the globe, earning degrees in every aspect of the field. Upon his return, he was ready to share his knowledge and new identity with the world. He has become Max Axiom, super scientist.